Welcome back from spring break, folks. It's Mrs. Sid doing a video for you today to kind of get a jump start on our notes for Wednesday. If you take a look at the date, it says 4/7. Today is the 5th, not the 7th. But if we saved all 4 pages of notes for Wednesday, there's no way we would get through what we need to get through. So I thought I would start off today, since we have the time, kind of introducing you to a log function. Before we go to a log function, let's go back to our friend, the exponential. So for those of you that were in class on Friday, you did a great job learning these exponentials. And those of you that were not in class on Friday, this might be a nice summary for you. All right, so y equals 2 to the x. It's going to look something like this. The domain is all real numbers. So terrible infinity signs the day after spring break there. Our range is parentheses 0 to infinity. The graph never touches this x-axis, and in fact, there's an asymptote there. That asymptote is y equals 0. X-intercept, there is none, and then the y-intercept, 0, 1. So the 3 points, I'm going to draw a T-chart here. 3 points are if x is -1, our y-coordinate is 1/2. If x is 0, we have a y-coordinate of 1. And if x is 1, we have a y-coordinate of 2. Now, the other way we saw exponentials on Friday is with a base of like 1/2 or 1/3. And so let's talk a little bit about what that looks like. Instead of going up or being an increasing graph, these are decreasing. So kind of looks like a reflection over the y-axis. It still has an asymptote at y equals 0. Domain is still all real numbers. Range is the same, 0 to infinity, where 0 is not included. X-intercept is none, and y-intercept is 0, 1. So this points at 1 there. And again, the 3 points, it's going to look very similar to this. Our x's are the same, -1, 0, 1. But instead of 1/2, 1, 2, it's going to go 2, 1, 1/2. And that's just plugging in those for that x, the exponent. So that's a quick review of what we did Friday. For those of you that were not in class, we also shifted these up, down, left, right. Some more exciting stuff going on. Now let's talk about these log graphs. This is the new piece that I'm hoping we can just bounce off of this when we meet on Wednesday. So let's talk about a log graph. Get a little smaller. So logs and exponentials are inverses of one another. So let me remind you a little bit about what an inverse is. The way we found inverses algebraically is we would switch x and y and then solve for y. So that is how we would do that algebraically. Now, how it looks on a graph is we would reflect over the line y equals x. So I'm going to use that idea. So y equals 2 to the x is here. Here's y equals x. And now when I think about its reflection over that line, it's going to look like this. So I'm going to erase the purple and the gray so you can see just that log graph. All right, domain for this, because it's because it's the inverse of an exponential, the domain and range are going to get flipped here. So the domain is 0 to infinity, and the range is all real numbers. We do have an x-intercept. It's 1, 0, but no y-intercept. The asymptote, well, it used to be along the x-axis. Now it's along the y-axis. So it's at x equals 0. This graph is increasing, and our 3 points, again, this is an inverse. So we're going to have to flip x and y coordinates. So that means if x is 1/2, get an output of -1. If x is 1, I get an output of 0, and if x is 2, I get an output of 1. And again, this is base 2. Remember, this will change slightly if it's base 3 or 4 or 5. Okay, let's do the same thing for the base of 1/2. All right, so that y equals 1/2 to the x, remember that looks like this. If I have y equals x there, what this is going to look like is I'm going to be going along this graph. There we go. So I'm going to erase the gray line, or at least try to. See if I can get it all. There we go. And there is our log base 1/2 of x. Still has an asymptote along the y-axis. So domain is the same, it's still 0 to infinity. Range is the same, still all real numbers. X-intercept, still 1, 0. And there is no y-intercept for the parent function. Asymptote, x equals 0. Now this graph, as I move from left to right, decreases. And the 3 points are going to be, well, we can always look back up here. The x's and the y's get flipped, right? So when x is 2, this is -1. When x is 1, this is 0. And when x is 1/2, this is a 1. So here are our parent graphs for logarithms. And that's really the piece I want you to take with so that on Wednesday, when we start, we can do some transformations. So that's going to be our key, or kind of our starting point for class on Wednesday, is to do some transformations here. Notice there's a 4x. So get these graphs down, and I will see you on Wednesday. Hope you had a wonderful spring break.